Okay, so lesson 1, 3, we're going to be messing with the midpoint a bit. So to start with, let's just draw ourselves a line and kind of get what the definition of midpoint is. Midpoint is something that would divide a segment. So if I had a point here and a point here, these are my end points. It would divide that in half. So this would be my midpoint, and I'll most of the time label my midpoint M just for clarity's sake here. And so the definition of midpoint is this. A midpoint of a segment is the point that divides a segment into two congruent parts. And the way that they define each point will end up looking somewhat like this. It is a coordinate on a coordinate plane. So it would be like x sub 1, y sub 1, and that'll be the first point. And then you'll have a secondary point, which will be typically labeled as x sub 2, y sub 2. But don't let those confuse you, because those are just points on a coordinate plane. So if we're talking coordinate plane, remember that's just the x and y axis stuff. So we have an x-axis, which is that left to right, and then we have a y-axis, which is that up and down. So if I said, okay, here's one point at, let's call it 3, 3, then the first point would be 3, 3. So that's where these two become interchangeable. So x sub 1 in this case would be 3. Y sub 1 in this case would be the other 3. And then let's use another point. Let's do this point right here. That would be our second point at the coordinate 1, negative 1. So for our x sub 2, it's 1. For our y sub 2, it's negative 1. And then we're going to make a formula, and I'll show you the midpoint formula as a definition here. And you're going to want to keep this. This is one of those things that I would put on a note card to help you get through it. So the midpoint formula is M equals big crazy parenthesis, because it's going to be a top and a bottom. So it's going to be x sub 1 plus x sub 2. And then on the bottom of that, we're going to divide it by 2, because we're just cutting it in half. That's why that divide by 2. And then we're going to add up the y's with y sub 1 plus y sub 2. We're going to divide that in half. And that's it. That's all you got to do. So to find the answer for this one, this example that I'm giving you, it would be this simple. I would take the x coordinate 1, which is 3, and I'd add it to x coordinate 2, which is 1, and I would do division by 2. And then I would take my my y coordinate 2 and 1 and add them together. So I'd have 3 plus a negative 1 divided by 2. And this is relatively simple. We're just going to literally do order of operations here. But 3 plus 1 being 4 divided by 2 will give us 2. So we've already got our first coordinate right there. And then I'm going to work the next one. It's going to be 3 plus a negative 1, which is really just subtraction. So if you want to rewrite that as 3 minus 1, that's fine. And then it becomes 2 divided by 2, which is 1. And that's the answer for the midpoint. The midpoint is a coordinate. So having parentheses, even in the problems online, you have to have parentheses in order to establish a midpoint. You have to have a set of parentheses around your coordinate. So coordinates always have parentheses. That's a big, 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 big thing. All right, so moving on, if you want to follow along in your book, you got it. It's on example 1, and you can pull that up from your, if you're looking for the book, you can go to browse and then hit the book and go to page 22. Or if you're in the assignment already, all you have to do is click eText from the tools menu, and it'll be right there. So this one gives us the coordinate plane of A. So you're looking at a picture here. Don't forget that I'm pulling these right off of a picture. Whoops, sorry, showed you the wrong picture. It says A is negative 3, 2, and B is 4, negative 2. And then we're going to find that answer. So the greatest part about the example is you can still work it as if you, the way that you think you know how to do it, and then see if you get the answer the same as they got the answer because it gives it to you right then and there. Copying here doesn't really help you all that much unless you are able to duplicate the process in a way that you understand. So here's the points. We're going to use the midpoint formula. So it's going to be the two x's added together. So I have -3 plus 4 divided by 2. And then it's going to be my two y's added together. 2 plus -2 over 2. And order doesn't necessarily matter here. You just have to add them together. If I had this as -2 plus 2, it's going to give us the same value, so it doesn't matter too much. So to find the midpoint of these, I'm averaging them. That's the way that I kind of understood this. I'm finding the average. I'm adding them up, dividing by the number of points I had, and I had 2. So midpoint is kind of the average. It's going to break them down into 2 equal parts, like we did on this example there. So add them up. -3 plus 4 is 1, divided by 2, comma. 2 plus -2 is 0, divided by 2. And then I have to simplify that. My answer is not good right there. I can leave this as a fraction. And typically in the assessments that you will take, they'll give you a box and it'll say leave it as a fraction, or you can put it as a decimal. So if it says decimal, you can put 0.5. If it says leave your or simplify your answer, it'll accept either of those options. For now, I'm going to leave 1/2, and 0 divided by 2 is just 0, so it's 1/2 comma 0, and I have a really messed up parenthesis right there. Okay, so that's example 1. They get a little bit harder when we start asking questions like, what is 3/5 of the way down this line, instead of just sole midpoint. So we're going to use this for midpoint. This is a big formula that you're going to need. And then we're going to use something a little bit different when it comes to finding fractional pieces. So we're on example 2 now from our notes on page 23. So it's going to come from that diagram there. So our first point will be A at 3, -4. And then we will go over to B at 13, 11. So I'm going to write down those points. 3, -4 at B is 13, 11. So this question says, what are the coordinates of the point 3/5 of the way from A to B? So the easiest way that I know to do these is kind of just to analyze your picture. That's the first thing that I do. I start seeing if I can break it down into 5 equal pieces. Well, 5 is a hard thing to break it down into, so this one's a little bit less, oh, I can just kind of look at it and get my answer. But sometimes you can just look at these things and say, oh, well, it hits perfectly right here, and that breaks it into 4 or whatever. But on this one, you have to follow a little bit better on the step-by-step. So it says find the 3/5 of the horizontal and vertical change. So you should remember this from, I think, 8th grade. You probably even learned it earlier than that. It's rise over run. So that's the first little note that you might want to make to yourself. It's rise over run. Put a little star by it, make it special. Just a reminder. So when I'm looking at a coordinate plane, I'm going to rise on that first number and run on the second number. That's what those two things are going to indicate for me. When I'm talking 3/5, that means rise 3, run 5. Rise 3, run 5. So that's what it means when on the question, on step 1 for this question, it says find 3/5 of the horizontal and vertical change. Horizontal change is the left to right. The vertical change is the up and down, better known as rise and run. So you're going to find 3/5 of each of the set of coordinates. So the 13 minus the 3 is the same as we were doing before. We are finding the difference between those 2 points. So you're essentially going to take your x coordinates, which was 3 and 13. You're going to find the difference between the two, meaning subtract them. So for ours, we're going to put B minus A because I want to not deal with the negatives as much. So 13 minus 3 and I need to find 3/5 of that. Of is a big indicator here again, multiplication. So let's see if we can solve this guy real quick. So 3/5 of, and we do parentheses first, so 13 minus 3 is 10. And then we can multiply that straight across by either rewriting 10 as a fraction, or if you already know how to do it, you can just multiply it straight across by doing like that. But to rewrite it, it looks like this. And then multiplying fractions ain't no problem. Top times top, bottom times bottom. And excuse the English, but it doesn't rhyme the other way. And 30 over 5. Now, some of you may have noticed, oh, I could have reduced here before I got to this. And if you want to do that, go for it. It's perfectly fine by me. Do it to it. But if we get to this point and we see that it needs to be reduced, which it does, 30 divided by 5 is 6, then now we know 6 is the number that we needed here. So we've got it as far as our x's were concerned. So x gives us that. Now we're going to look at our y. That's our vertical change. That's the up and down. So we're going to take our, again, b minus a, because I did that in the first one. I've got to do it in the second one. I'm going to take it and I'm going to leave you a little bit of space. 11 minus -4. If you work too fast, you will forget one of these two things. Don't work too fast. Okay, then you got to set up another set of parentheses and find 3/5 of that number. You should remember 2 negatives will make a positive. So you can either change that within here or rewrite it. I'm going to rewrite it. So it becomes 11 plus 4, which is relatively easy to answer. So I need 3/5 of 15. So break it down into fractions. I'm just going to go ahead and keep working right down here. So 3/5 of 15 over 1, top times top, 45, bottom times bottom is 5, and reduce. Again, if you see that you can reduce before, do it. 45 divided by 5 is 9. So there we go. There is our y coordinate. And to go back and answer the question, we have to put those two things together. So we would say that 3/5 of the way between A and B is the following coordinate. Oh, I did that. No, I didn't do that wrong. Would be our x value 6 and our y value 9. Right there. So what we have to do at the end of this, that's our coordinate, and this is 3/5 of the way, is a change of 6 and a change of 9. So this is the way I would like to do this kind of at the end. I have to add these up because I'm going to take them from A. Let me show you all right here. I'm going to take them from A and go to 3/5 of the way. Okay, so because I'm going from here to 3/5, I'm adding them up. So this is what I do. I just take this point and I stack them up on top of each other. Oh, I shouldn't have circled so much. 3, -4. And then I can add them straight down. This just makes my life slightly easier. But if you want to, you can break them down into separate problems. And you add them up, you would get 9. And 9 plus a -4 is 5. So the actual answer, once you get down to the end of it, little thing is in the way here. It's 9, 5 for the final answer. So there's multiple steps in this one. Really, there's 2 steps once you find 3/5 of it. So you're going to find 3/5 of each coordinate and then add it to the starting coordinate. Okay, if I was trying to do that with B, I would have had to have subtracted it because I'm going from here down. But because I started at A, I had to add it because I was going from there up. All right, moving on to example 3, still on page 23, but example 3. This one asks, how can we find the distance between 2 points, P and Q, on a coordinate plane. So this one literally uses nothing except for these two values, which are not real numbers. But it still works exactly the same. It just says to subtract the 2 and find it. So we're gonna find the distance formula using these two values. So point P was exactly the way we started describing it right there at the beginning. X sub 1, Y sub 1. Again, no numbers. And then point 2 is going to be Q, and so that one will be X sub 2, Y sub 2. Now that all sounds pretty, already I'm looking at that going, yeah, that's a lot of letters. When did we get into English? But if you look back here, any 2 points on a coordinate plane, when we're talking the distance between the two of them, that'd be the hypotenuse. Remember, the hypotenuse is the longest side of a right triangle. But if you just draw a straight line down and a straight line over, you always make a right triangle. And if you remember something very important about right triangles, you can use the Pythagorean theorem to find basically anything that you want to find about it. So using Pythagorean theorem, we can find distance. So it really just means, hey, find the length of this side, find the length of that side, and use Pythagorean theorem to solve it. And I'm just going to give you a little bit of a reminder of what Pythagorean theorem looks like. If it's gonna help you, I think it's gonna help you. So let's talk Pythagorean theorem. And if I spelled this wrong, somebody's gonna have to correct me, but I think I may have got it. Anyways, it's a squared plus b squared equals c squared, where c is the hypotenuse. So c is the longest side. So the two shorter sides squared added together equals the squared of the longest side. And we're going to use that to find this. Well, the only thing that you got to do to find the length of this side is subtract the vertical distances. So I take the two y's and I subtract them. I take the two x's and I subtract them. So now I got the lengths of the two sides, which makes it relatively simple. So if I want to find A, which is one of the sides, I would just subtract the two sides. And the way I'm going to write this formula is to help you most of the time. But sometimes you may want to use just a little bit of common sense to make your life a little bit easier. So I'm going to subtract these two. Because the second point is typically a larger value, because it's typically up, I'm going to put the bigger value, which is normally the second point, and I'm going to subtract it from the smaller value, which is normally the first point. So that's where this first part of the Pythagorean theorem comes into play. I'm just finding the length of one of my legs. So that's going to be my A, and I have to square it because that's part of the Pythagorean theorem. Then I add it to the length of my other leg, B, which is really just the difference between these two. So I would just subtract these two. And then I would square it. And it would equal c squared, which is actually the distance. So instead of c squared, I'm going to use d for distance, just so that it's easier for us to remember what it stands for. It's the distance formula that we're deriving here. Squared. So a squared, which is the length of one side, b squared, which is the length of the other side, and then instead of calling it c, I'm going to call it d for distance so that we don't get confused later on, squared, which is the length of the longest side. Now, I could stop right here. The formula still works, but what I want to do is I want to get distance by itself. I don't want distance squared because they're going to say, hey, what's the distance between these 2 points? I'm going to say, what is the distance squared between these 2 points? So I need to get rid of squared. I need to perform the inverse operation is what that's called. The inverse operation is square root. So how do I get rid of a squared? I square root. But what I do to one side, I have to do to the other. So those squared and square root cancel right there. So I'm just going to rewrite it. I guess I'll use the lowercase d. Distance is going to be a really big square root sign, and then all of this stuff that we had already written. X squared minus x sub 1, or sorry, I said x squared. X sub 2 minus x sub 1 squared plus, open parenthesis, y sub 2 minus y sub 1, close that parenthesis, squared. Okay, so this is your formula. We're going to use it here in a second, but this is your formula. You need it, you need it, you need it. Put a star next to it, highlight it, put a big bold box, do something crazy because you're going to need it. Last example, here it is, example 4. And example 4 goes to the distance formula. So it gives us a picture, a nice little picture, and then asks us a question about distance, obviously, right? So a pitcher throws a ball to a batter who hits the ball to the shortstop. If the ball travels in a straight line between the two, so we're talking about the distance from the batter to the shortstop and the connection between the two. So first thing we need to do is be able to read the points on the plane. The batter's at 0, 0. His job, or his coordinate, is really easy. So we're going to write down the batter's coordinate. I'm going to use him as B in this case, and I'm going to put him at 0, 0 because that's right where he was. And then we have the shortstop. I'm going to call him S, and then we need to find his coordinate. So going over here, jumping over to 5, comma 10. So his coordinate is 5, comma 10. We're going to use that little formula that we got right here. So first thing in our formula, it's the square root, biggin, of, and I'm going to take the big one, subtract the little one, because that's easier. I don't have to deal with negatives that way. So it's 5 minus 0 squared plus 10 minus 0 squared. And then what this equals will be our answer. So let's start solving it down. I need to get down to the smallest groups that have already been established, and these are the smallest groups. Smallest group right here, this turns into 5 squared plus, that turns into 10 squared, and then don't forget about your square root. So I get 25 when I square 5 times 5, and I get 100 when I square 10 times 10. I add them together, becomes 125. So you want to be careful on how they ask for your answer, because the distance between the batter and the shortstop answered as 125 kind of sounds, the square root of 125 kind of sounds silly. So if you have a calculator, which you should, there's one on almost every device, including a cell phone. So if you turn it sideways, your cell phone actually will have all this stuff for you. So you can take 125 and find the square root of it. You don't even have to really think too much, and it gives you the answer. Typically they'll say, hey, round your answer to a specific number of decimals or tenths or something like that. So on this one, it said round your answer to the nearest tenth of a foot. So since our answer was 11.18, tenths being this one right here, I'm gonna have to round that up. So it'd be 11.2. I'm gonna approximate this. So to approximate, you wave your equal signs. So approximately 11.2 feet for my answer. And that is it. The distance between my batter and my shortstop in this shortstop in this particular one is supposed to be 11.2 feet. And that's it. If you look under concept summary, they'll give you the formulas right then and there, your distances, and then it gives you a little bit of more examples. I hope that helps, guys. Bye.